Hot chocolate, Azure, Cosmos,
Entity framework, our tools.
Netforgy suite.
Countdown commencing. T-minus 2 minutes.
Jeremy Lickness.
Shiro Jan.
Chris Lanson.
Arthur Vickers.
.NET data. T-minus 1 minute. Thirty seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff. We are go for .NET Data Community Stand-Up.
Awesome. Good afternoon, evening, morning, whatever your time zone is. It's another month, another .NET Data /EF Community Stand-Up. Today we have a great topic because Couchbase recently released EF Core provider. So we will be talking about EF Core for Couchbase, which is really interesting. Another typically non-relational database with a couple of twists. So I'm really looking forward into this one. If you are looking for Shai is busy with other things. So it will be just me and basically Couchbase. So you will have to deal with it. I will have a little bit more on my plate dealing with chats and studio and everything, but hopefully we will do it. As usual, let's talk about current preview that you can download with EF Core and you can play with it. It's preview 6. We are actually closing now with the code for preview 7, which, as you probably know, is the last preview. Then we will be entering the phase of basically release candidates. So the preview 7 is the last one, but it's going to happen in a couple of days. Still preview 6 today. So if you want to play with latest bits, you definitely can. And the preview 6 of EF Core 9 contains a couple of interesting features, or at least one interesting feature. And it's named query filters. Maybe you know EF has for a long time query filters, but you always had to specify the query filter at once, completely. And if you wanted to have something that like enables, disables something, it was a little bit difficult. So now if you are creating a query filters, you can give it a name, which is a random string you want. And then you can selectively ignore query filters, meaning that you have like 2, 3, these two are combined together. And if you ignore only one, that only this one is ignored and the rest is still there. So your where conditions and everything will contain those. There's also small improvements and bug fixes that are coming in. A couple of notable ones is that now if you use date only date number, we translate it into SQL, and you can use it. You can have a condition on it, and so on and so on. And also a little bit of breaking change. We will be definitely documenting the breaking changes for the release, but for now, we changed the default default compatibility level for Azure SQL to 170. So if you are using the SQL Azure or Azure SQL with our provider and you don't want to bump it into the newer one, which is question why you don't, but anyway, then definitely check that out and adjust your code accordingly. With that, I think it's time to bring our guest for today. So there it is. It's Jeff from Couchbase. So introduce yourself and tell us a little bit about you and what we can expect in the next, 55 minutes.
Okay, great. Hey, my name is Jeff Morris. I'm a senior software engineer at Couchbase. My responsibilities are I'm the lead of the the .NET SDK team and all the satellite products around that SDK, including the EF Core framework, which is our newest release. Besides that, I do a lot of things. I like surfing, fishing in my free time. I love reading, technology. I like to keep things busy and stay active.
Nice. Awesome. So I will be playing, as usual, the dumb one here. And tell me, what is a Couchbase actually? Or tell the audience what a Couchbase is and why they should give it a try.
Sure. So Couchbase is a distributed database. It's what we call back in the day, it's a NoSQL database. So it's not like a relational database where you have tables and schemas, etc. We store JSON documents. We also store binary data, but that's an aside kind of. Our core strength competency would be JSON data. So we store JSON documents, unstructured. You can enforce structure on the application side. You can use, JSON schema. And if you're using .NET, you're just going to use the actual POCOs themselves because they will define your schema and keep things tidy. Besides being a NoSQL, we're a key value database. So as being a NoSQL database, we're a KV database. So that means we store our documents based on a key. And the JSON itself is the value. So if you want to fetch a document, you take it, you get your key, and you make a request, and you get back a document. That's serialized into your POCOs. Typically, you can use dynamics, but we generally do not, advise that in production. On top of that KV store, we have a very robust SQL++ layer. So what that means is, even though we're a KV, we're a NoSQL database, we're fully functional operational database like a relational database. And we have a very strong query language, SQL++. SQL++ is just how would I put it? It's just a superset of SQL with some extra fancy things that allow it to go nest or unnest a JSON document. If that's your requirement. It's designed specifically to work with JSON, but it looks just like, ANSI SQL. There's nothing really different, too much, maybe slight syntax differences here and there. And that's what you get with any dialect of SQL, across, like, say, Postgres versus SQL Server.
Yes.
They're all slightly different.
Exactly.
On top of that, Couchbase has transaction support, indexing support, a whole list of features that you would expect with just your relational database. But like I said, you get this flexibility of JSON, and the strong, the strong SQL support as well. There's
Okay.
a whole ecosystem built around it, connectors, etc. This goes outside of just .NET. We support Java, C++, Rust, Node, all different languages from the perspective of the SDK.
Wow, nice.
Yeah. So even raw and also raw HTTP requests if you want. We do have an API, even though that's not used as much because you get a lot from the SDKs because the SDKs do things like retries.
Oh yeah, of
They
course.
know since we're a distributed database, right? Nodes can be dynamically added or removed. Okay, so you could scale out horizontally. And if the SDK, isn't aware of these changes, you're going to have problems, right? So just assume a node a key was mapped to a node, and then that node was dropped because of some issue, server crash or something, and you made a request to that node, right? It would fail.
Of
So
course,
the SDKs are smart enough to say, hey, look, this request failed. Now let's remap we'll receive what's called a cluster map. And what we'll do is we will reconfigure our client dynamically to match the current state of the server. So that node that was removed will now be removed from the SDK as well. And then it'll be retried. And then hopefully it'll arrive safely at its new location.
Right. There is a question that I think nicely relates into this, let's call it internals. And it's which data structure is used by Couchbase to manage and organize its indexes. For instance, B+ trees, LSM trees, or another type.
That's great. And it's somewhat out of because it's changed over the years. I've been there quite a while and things have changed. In the past, originally it was the B+ trees. And it may have changed since then. We've had a lot of optimizations done, a lot of changes. I've been in the company around 13 years, and it's grown a lot, and things have changed a lot. And then with that, optimizations have come up.
Right.
Yeah. So I believe, gosh, it could be LSM. I really am not. Like I said, that's the internals of the actual server. And I'm not as strong there as I am with the SDKs and what the SDKs can do.
That's fine. We have the answer from your colleague on the chat. So for the people watching, it's still B trees.
Still B trees.
Nice. And he also says there are other indexes for like full text search, inverted index, and everything. So I think that answers the question more than enough. Awesome. You mentioned that Couchbase is a distributed database. And does it mean that I can have multiple nodes even like in different locations, like geo-distributed database? Or does it need to be, let's call it local, so these nodes will talk to each other a lot?
No, the configuration's very, how do I put it? So we have a very strong cloud presence, especially with our new offerings. And with that, there's a lot of configuration options in terms of where you're located, what available is on, et cetera. So it's like I said, it's a very robust, it's a robust product, and there is a lot of configuration that allows you to do things like what yeah.
So let me put it slightly differently. If I have a cloud application and I have two zones, two data centers, let's say East Coast and a West Coast, and for whatever reason the East Coast goes offline, am I still operational?
Yes.
Can I survive this one?
There you are. Yes.
Nice. I was expecting that, but
yeah. Yes, for sure. It's like I said, it's somewhat outside of my expertise, especially the last couple of years. But we're very, like I said, we're very robust, and you can, if you go offline, you can switch over to other data centers, et cetera, or different availability zones, et cetera.
Awesome. Okay, so let's jump into EF. If you want to bring your screen in the meantime, we can do that. And I will have a question to that. Why did you decide to have EF core provider? What was the tipping
Okay.
point, let's say?
Yeah. So let me go back a little history here. Okay.
Okay. Yeah.
This is this will take a little bit of time, but it plays into the whole story, and it tells us how did we get to where we're at now, and that is with EF
Mhm.
core. So originally we just had an SDK, and this is around 2013, 2014. And at that time, we started to get requests for a link layer.
Mhm.
At first, it was EF Core. EF Core was so new at the time. I believe it was very new or just coming up.
Yeah.
And link providers were still a thing, even though they were officially kind of put in the closet, so to speak. They were
Yeah.
not. They were saying, "Oh, everyone's use EF," and so I started doing some research. We had customers that wanted this link support, and after some time, I don't think EF was the product it is today. It didn't have the maturity, and
Mhm.
definitely didn't have like the developer support that it does today.
Mhm.
So what we did is we started. I started a project, excuse me, just an open source project to get. I think it's around 2015 now, and at this time I was actually a dev advocate at Couchbase.
Okay.
So one of the conferences that we had, a couple of weeks before, I started just playing around with iQueryable, and I ended up with a very crude link to Couchbase. So we called it
Mhm.
link to Couchbase implementation, which was a link
Yeah.
provider that emitted that SQL++ dialect. And this is also when we just started with SQL++ because originally we didn't have in the product.
Mhm.
So this was our kind of introduction. And so I started this, and I think the first iteration was like select. You could select documents based on a key, I believe, something like that.
Yeah.
So, anyways, this took off. Actually, it happened to be in the audience. There was a customer who had a lot of need for a link provider for Couchbase,
Mhm.
and he took off on this open source project, and basically created an entire link provider that supported most everything you're going to want with SQL++.
Okay.
So he did this, and it's popular. It's still out there today. It's super popular. It's not currently getting developed too much because it's pretty much complete.
Mhm.
Now, as we had this link to Couchbase provider at the same time, EF Core was becoming, or EF was becoming, before Core was getting more and more popular. And developers
Got
started
it. Yeah.
asking we said, hey, look, we have a link provider, but they're like, we want EF. We want an indie
Uh-huh.
framework. We don't want it,
Okay.
and they, so we made an attempt at an EF provider. And what we did is we took the link layer that was on top of our link provider, which was based on Remotion Relink, which is an
Yeah.
old open source. Basically, it got you basically did all the heavy lifting if you're going to do a link
Yeah.
provider. And we lifted that, and then we started, and then we were going to apply it over the SDK and over all the EF core stuff, the extensibility parts. And
Mhm.
then we started it, and it just went nowhere. Unfortunately, it went nowhere. It was like 2019, maybe. It went
Okay.
nowhere. I got moved off of to a different project. Excuse me. Um, and it just fell apart. It didn't work out. And we kept getting requests for, hey, we want an EF provider, and even though you have a link provider that does a lot of stuff, it doesn't do everything that EF Core does. And at this point, Core had come out just then, around 2019, 20, if I believe correctly. So that sat for a couple of years, and then maybe 2 years ago or a year and a half ago, the demand started to increase, and then with that demand from the customer base, we started looking into, let's do a real one. Let's do a real EF core, not a hybrid. Let's do a real EF core provider. And so anyways, that's where I got involved, and I was kind of front running the project, and doing a lot of research on EF core. It'd been quite a few years since I'd actually looked at it. Gosh, I had a lot of experience with NHibernate. This is way back when. A little experience with EF, but no experience with EF core. And I'd heard a lot of great things about it, and everything I saw about it I really liked, and I was like, wow, this is really great. This is and the way they've designed it now is it's extensible, right? You can build your own EF provider, and they give you much of the heavy lifting, just like for example, Relink did. And so then it came down to what do we want to do? Which direction we want to go in? If you look into EF core, there's kind of two parts. There's EF core, and then there's EF core relational. So then we got to the point where it was the discussion was really, where do we go? Do we go EF core, which like for example, Cosmos is based on EF core. And it does some heavy lifting, but it's just a lot of work you need to do. A lot of work you have to do with the internals, the shaper, a lot of visitor pattern. It's fairly complex, and we looked into that. And, you're always looking at, when you have a product that you want to release, you look at level of effort, you look at time to market. You kind of have to weigh these economics of software development, right? You don't just, you don't just willy-nilly go at it. You go, what's the best bet for us? So then we looked at the relational side. I had some discussions with the developer, the Brent Burnett, who was the developer that did a lot of the Link stuff. We talked about it, and, Relink is really, it's gone. And he didn't know a lot about EF core at the time, but we talked about it, and he's like, you should try the relational side. He made a suggestion. Why don't you look more at relational instead of building everything up? Because that's really what Relink did, Relink did, is it was more like the relational side, and then we just had to adjust. So when it went down a relational path, you had to either go left or right. You know what I mean? You couldn't keep going down that path. You know.
Exactly.
So kind of long-winded here, but so then we went down the relational path, made the decision, and then it was just a lot of kind of false, not really false starts, but learning. A lot of just learning and debugging like the SQL Lite provider and the SQL Server provider, and seeing how HIT did things. Just each provider, while they do the same thing, they all do it somewhat a little bit different. Not exactly. Some things are very close. Some things, and you don't know really, because they're different implementations. You don't really know why did they go this way and that. So it's a lot of it's just learning and getting that knowledge base, building it up. And so we kept going with it, and it started really working out. We were really impressed with the design of EF core and EF core relational. And we were really impressed. We're like, you know what? I think we can just take the EF core relational stuff and find out where we need to tweak the dialect. Excuse me. Because we're going to emit SQL. So we just had to tweak that dialect to match what's in SQL++. And so it ended up with, I started adding a whole bunch of code, and then I started removing a whole bunch of code, and finding that using these integration points, we were able to make a lot of progress. So going down that path, we just kept going with it until we finally got to the point where we started using the specification test to kind of, validate what we were doing. And and it started to work out, and we got to the point where, we don't cover everything, and there's definitely some shortfalls, but there's also the major paths that you expect in a SQL in a EF provider. We had that completed. It worked, I wouldn't say completed, but it worked, and so
just to give listeners a little bit of the context, because obviously you and me, we both know what we are talking about. EF Core, although it started as a object relational mapper, it's now not only relational databases, and we have these layers, and there are two distinct layers that we are often talking about, and one is called EF Core and the other is called EF Core Relational. In fact, if you are downloading NuGet packages, you can see those packages as a dependencies of your provider. And the core EF core has no assumptions about relational stuff. Well, at least that's the theory. We still have a little bit of bleed into this one, but at least we want to have this core package to be absolutely agnostic about what type of store you are using. Documents, key values, relational, whatever. And then we have this relational that for you as a consumer gives you the stuff as like mapping something to a table or mapping a property to a column, because that's what the relational databases are usually using: tables and columns and indexes and store procedures and so on. But obviously, if you are using a different database, like you mentioned, Cosmos, that's not based on the relational because it's not a relational database. And if you're writing a provider or starting writing a provider, obviously the relational package gives you a lot of stuff, from basically taking the link expression, link query, and translating it into like tables and rows and columns and stuff. But if you would be starting from scratch, you would have to do this by yourself. So it's a question always like, do I really fit into relational, especially if you are not a relational database? And if so, how much? How much I will benefit from using the relational layer? Or if not, like how much I am going to implement myself that's maybe very similar to Cosmos or other providers that are out there.
Yep.
Awesome. Do you want to show us some code?
Yeah, I can. Give me just 1 second here to get set up.
No problem.
And okay, can you see my screen now?
Not yet.
Okay.
Still nothing.
Let's go to
in StreamYard, there's this bunch of buttons on the bottom, and roughly in the middle is a screen sharing.
yeah,
It's
I
a
see
screen with a
that.
plus in the middle.
Share screen. So I'm going to switch to, I cannot share my ID for some reason.
Mm-hmm. That's no problem.
So what I will do is switch to a slideshow that does have
Okay.
some code. Slightly.
Awesome.
Yes. Yep. Can you see that?
Yes, it's on the stage. We can see that now.
Great. Okay, so this is a presentations. You know, a lot of the stuff that I discussed I've already discussed, so I'll kind of skip over those things.
Absolutely.
But I talked about link to Couchbase and how we can went from link to Couchbase to EF. Some of the limitations of link to Couchbase. You know, I talked about that. The developers wanted something that was more robust than just a link provider. They wanted a full-blown entity or full blown ORM, so an object relational mapper.
Mm-hmm.
And also EF Core grew, so it no longer used remotion relink and switched to EF Core. EF Core, like we just talked about, had this extensibility added to it, so we want to embrace that. We talked about EF Core versus EF Core Relational. Once again, one was designed kind of with that relational flair, so it gave you a lot of heavy lifting, got you really close to the relational model. And then the other one was kind of bare bones, and you had to kind of build your way up. For example, Cosmos is the provider, or the EF Core Cosmos is EF Core. And then, like, say, SQL Server or SQLite is EF Core Relational. We also took that approach. We took EF Core Relational. We felt that because we had such a robust query language, that it would be a natural fit, and it turned out to be. And there was some definite gotchas here and there. One of that was when we ran into ADO.NET. And that's kind of a story for another day, but we worked around ADO.NET, so to speak. Implemented some things, and a lot of things we just let it go. ADO.NET, if you don't know, is the kind of the base database API for .NET. I'm going to switch that, and so we came to this thing is why do we want to use EF Core? Why don't we use Relational? We ended up using Relational, and it was good. We got basic projections queries, SQL++ functions. The dialect was slightly different, so we had to go in and override a bunch of methods for count, contains, etc., and just admit the dialect that worked with SQL++. There's a few things that don't work. Eager loading is something that we put out there, so it's something that we're going to have to approach in a later version. There's some SQL++ functions. This is a little outdated, so there's actually a lot that do work now. Of SQL++ functions. Value generation is something that we put out for a later release. We don't really have support for that at the moment, but we will eventually.
Nice.
And then there's a few things that are very specific to SQL++. The meta keyword, read your own rights, for example, and these are all related to distributed databases and whether or not it's whether or not you're reading from a master copy of the data or it's a replica, et cetera, like that, et cetera. And like I said, we talked about this already, so I'm just going to skip ahead till I get to the code part. And we did find there was some, this is an early slideshow, by the way. So we did get some bottlenecks, or not bottlenecks, some roadblocks, and that was mainly with ADO.NET. And that was largely because ADO.NET, right, it expects a relational database. A relational database is composed of tables, and tables have columns, and they have other tables that contain metadata, and all that works together so that you can, insert data and do joins, et cetera. It all works together. But with JSON, it's just different, right? A lot of that metadata is actually in your POCO. It's not in the database itself. You own that metadata. And also, we're not working with columns. We're working with properties, and properties can be like a scalar. They can be an object. They can be a list. So they could be a lot of different things. So there was a bit of a challenge there. I'll just briefly go over this right here. This is kind of the architecture as we saw it, right? We have Couchbase on one side. We have your ASP.NET applications that are depending upon the Couchbase EF Core provider. And then you have all the internals of the actual entity framework. And in it, we had to make some modifications, right? So what you see here at the top this is where we had to do some modifications to make it fit into our Couchbase world.
Yes.
And a lot of them are really, I'll be honest with you, in itself, the way EF Core Relational or EF Core in general is designed, all this stuff is very open, for the most part, very open. There was occasionally we would run into an issue where we had a closed class or something, or a sealed class. And what we would do is we would just include it into the Couchbase EF Core framework and then modify it as needed. So we had a worker. It seemed like every bottleneck or every roadblock had a way around it, which was really I was very very happy about that, and it was a testament to the scale or the extensibility of EF Core and EF Core Relational.
Just a little bit of the context for the viewers. We have in EF, basically everything in EF is public. We just have an internal namespace and a couple of attributes. So if you are like playing with EF and you would like to modify something, given that everything is public, you can, minus some helper classes or helper methods. And these internal ones, they are still public, so you can override and whatnot. But we just don't provide you the contract that we will not change it in next version of EF or something like that. So once you start touching the internal stuff, you can still touch it, but there's a great chance that in next version of EF, we will maybe rename the method or add extra argument or something like that. But overall, even for me, I'm writing a provider for a database called Firebird. It's usually acceptable because most of these changes are like compilation errors. So these are easy to fix. And usually it makes sense like, hey, there is an extra parameter called name. It makes sense because it's a table with the name or something like that. Yeah.
Correct. And let me add a little color to this. When I said sealed classes, I'm actually talking about when we looked at, say, SQLite and we found something in there that was very useful for us to have. Right. And either we could have written it ourselves, or we could have just brought it in. And with the understanding, with the expectation that it may completely change. And in that case, we're going to have to do some work to get it to change it, to make it capable or compatible, excuse me. And so one of the main points one of the main features of EF Core is the DB context, right? So the DB context, it's your table, so to speak. It's I don't know how to put it. Not so much your table.
It's your database. Yeah.
It's your database. Yeah, it's your database. Yeah. It's your view into the database, so to speak, or your access to the database. And in it you'll map collections to tables, and then you can query against those, or you can do joins, etc. And so there was this, bit of an impedance mismatch, right? Because we didn't have tables, and we don't have tables in Couchbase, but we do have JSON. And if you kind of think about these things abstractly, they're really actually quite similar. They seemed very dissimilar, but when we went down to it, they were similar. It was just a matter of mapping things, changing the mappings in a way where the DB context was aware of, hey, we have this concept of a JSON document, and the JSON document has a type. So we put a little extra information in there to say, hey, look, we have a type. At the POCO level, that type is just the class name. Right. But we can do is store multiple instances of that class as JSON and keep the class name. And that is somewhat like a table, right? And then the columns become the properties. They're just a little more, well, not necessarily robust. They're just a little different on the Couchbase side, on the JSON side. And additionally, while the DB context is a database, in Couchbase, we've traditionally called our databases, so an instance of a database instance is what we call a bucket. And some of the newer product offerings, the terminology has changed to database, which is coming up. But in general, we call it a bucket. And a bucket is really just a database. It's just a store for your JSON documents. And it's got indexing. It's got everything, a normal database would have pretty much, just slightly different. And in the middle here, you have your POCO, plain old C# object. And on one side, we map it to a table. On the other side, we map it to a JSON document.
Yep.
And going forward, Couchbase, while it does have buckets, it also has, within a bucket, you have what are called scopes and collections. And we call that a query context. So the query context is basically bucket.scope.collection. And that allows you to store things similar to like a table, right? It's the same concept. You say, I want to store this JSON document in a collection. And in this case, you don't actually have to include that metadata type name. You could just store it in a collection and then query the collection and know that you're only going to get back a specific type of, like say, for example, a course, right? Every document in that collection is going to be a course. And so when we map them, you map it similar to how you would map to a database table. It's just slightly different. And this syntax right here is slightly more verbose than the current implementation. So if you went to like NuGet and you downloaded Couchbase.ef core framework, it's a slight different change here in that you don't map the bucket at the at the entity level. You map it when you configure the provider itself. And then you reuse it over and over again. Yeah. Scope and course, though, yes. And then the scope and the course are still there. This is a little confusing because the course and the collection name happen to be the same. But that's just it's just a circumstance.
Right.
Actually, I do mention right here that, yes, it's a future enhancement. Well, that is in there now. Anyways, that is how you map a POCO called course to the bucket Contoso, a scope called course, and a collection called course. And by the way, the bucket name, once you define your bucket name, you can use any name you want for your scope and collection. But be aware it is case sensitive. JSON itself is case sensitive. Yes. Right. So this is really important. JSON itself is case sensitive. So if I map in the database, in the Couchbase bucket, I say, hey, I want a scope called course. It must be, if it's lowercase, it must be lowercase also in your query going in and in your JSON document. And then, I'm just going to go past this, but yeah, primary key mapping, it's in there. There's not much to do here. It's done, but there are some additional ways to do it using attributes, etc. I'll just quickly go through this. This is a lot of stuff that this is where you're mapping a key to an instructor. This is just advanced, kind of a slowed advanced stuff with EF Core, but it's stuff that you can do with the relational database. You can also do with Couchbase.
Is there some limitation on basically the data type that the key can be?
Correct.
Or can be anything, string, integer, GUID, whatever?
So it actually, in Couchbase itself, it's always going to be stored. I'm really glad you mentioned that, because in Couchbase, it's going to be always stored. The key for a document is always a string.
Okay.
You can't store, you can't use an integer, but the Couchbase provider will translate between an integer in this case and a string.
Yeah. Okay.
Yes. And then when it comes out, it also does that translation. Because when we did this, we didn't want to create an EF provider. This kind of makes sense. We wanted to be influenced. We wanted it to be like replaceable with other providers, EF Core providers. and we didn't want to do things that were, so we actually, instead of molding it to Couchbase, we did the minimum we could do. We molded Couchbase more to EF Core to make it more like a traditional EF Core provider and make it easier to transition. Yeah, it was really it was something that we designed decisions that we kind of threw back and forth.
Yeah.
And so it is opinionated. And that's what you see here. It is very opinionated, and it's very much like, and it even stores the actual documents slightly different than how you would store things in, say, like a normal, like, hey, if you could store your JSON document in Couchbase in any way you want to. But we sort of normalized it in a way. So when we store it, we store the individual documents independently of each other. And then we allow the mappings within EF Core to be generated, because EF Core is I should say, intelligent enough to know how to map these documents based on the metadata defined here, and pull it all together. So when you fetch your document, you also have access to the relationships and the other sub documents, etc.
Oh, nice. Okay.
Yeah. So this is a total. So just like in EF Core or like say SQL Server, you have to create your own DB context. And this is the example from Contoso, and this is our school context. And as you can see, it's really almost identical, except for on model creating, to what you would do if you were using SQL Server or SQLite or Postgre, any of those. Like I said, this is that on model creating, the mapping is slightly the mapping is slightly verbose here. You don't have to define your bucket at this level anymore. You define it when you configure your EF Core provider and inject it into your application.
Right. But other than that, I can definitely tell that it's absolutely clear, like clear DB context that you would create in like starting with EF 101 or something like that. There is no magic, nothing like that. So it's really nice, clean implementation of provider. Yeah, really nice.
Oh, great, thank you. And so, as you know, what we did is one of our goals, like I said, was to make it basically just a regular EF Core provider and not make it something that was, even though it is a Couchbase EF Core provider, that's really just the storage location. We didn't want it to shape it based on Couchbase's different data model. So what we did is our litmus test was the Contoso University sample application. So this is how we started development, actually, is we took the Contoso University application, and then we literally just started, we injected the Couchbase provider into it, and then we started running through it and then fixing things. And the goal was to complete it without making any changes at all to the source code of Contoso University.
Wow,
of course, yeah, that was our goal. Our goal was to do it where it was basically you made a change to your configuration, and then you're good to go.
I like it because that gives you kind of like a clear, let's call it acceptance criteria, right?
Indeed, yes, correct.
So, yeah, nice.
And in practice, we didn't get 100% of the way there, but we did get, I'd say 80 to 90% of the way there. And some of that was because we just there's just few things that we had not implemented yet. And so anywhere, for example, in Contoso University, where there was a reliance directly on ADO.NET, we had to change that code. So we made changes.
Yeah.
And that's an example. That might change in the future, but for now. And then there's a slight changes with the DB context, obviously, and that's just a map to our model versus a relational model.
Yeah, of course. Yeah, that's absolutely required, basically. Yeah.
Yeah, so we did run a lot of. I actually really talked about this, but we talked about the challenges. I don't need to go. I don't think we need to go into too much detail here. We've already talked about this, and that was just basically, at first we were lost in this world of, which side do we go? EF core relational or EF core? We
Yeah,
made the
I
EF core
remember we had
relational
a meeting
decision.
about it and long this not a long discussion, but some discussion about this decision because obviously both have its pros and cons.
Absolutely, and we had great feedback from you guys. It was great to get that from kind of some validation from you guys to take it the direction we went, and it's worked out so far great. So we're really happy.
Awesome.
Yeah, I'll skip this most of it, and you know what? That's the end of this presentation, and I'll just stop here. And you stop for me. I appreciate that. Thank you.
Awesome. We have kind of a related question. Let me put it in here. And it's so given you add some conventions for the store buckets, can we assume there will be no database first support? The
Not at the
database
moment.
first, we usually call it when you have a database and you generate your entities, your objects from the database itself, like from some kind of metadata.
Yeah, model first, I believe, is the original
Yes.
kind of model first is a concept. Not currently. There's a few things that we had to absolutely just skip. So model first skipped. It was outside of the scope for the current implementation, and didn't quite fit as well in that Couchbase model. Another thing was migrations.
Yes.
We skipped that because it didn't make sense. We actually looked at Cosmos as kind of what does Cosmos do? And there's a lot of things that Cosmos does or doesn't. A lot of it does, but there's some things that it doesn't do, and there's a limitations. They actually have a Couchbase. Actually, all the providers that I've seen, or most of them, have like limitations of some kind because they're not all the same. They're all a little different. And so there were certain things that we just, from a time to market perspective and a need perspective, we just left them out in this first generation. They could make them in there later, but it'll be in a later version.
Yeah, that absolutely makes sense. And I would say nobody, at least I wasn't expecting when you first contacted us with like, we are doing this. I wasn't expecting that it will be like 100% compatible with everything. And I like the minimal approach, like let's get it out of the door, gather the feedback and everything, because let's face it, querying is probably the most important part of like EF or people for people using EF. So that's definitely super nice that this is supported, and other stuff like database first or migrations and other stuff can be improved later. I saw some questions somewhere in the middle. Let me think where I can find it. Oh, there it is. In the SQL query generator shared between provider implementations, is that why there is a SQL++ to SQL mapper?
So the query generator is shared, but we that's where actually a lot of that's like one of the key parts where we do the translation between SQL and SQL++. I think I'm answering this correctly. So what we did is we're overriding a lot of methods in there and then providing one that matches the dialect of SQL++. That was what we found to be is one of the greatest like implementation points or integration points that we had. And it was just a matter of it was kind of a godsend to find that, because that was really like, wow, this is where we can make a lot of progress here without going deep into the internals of the visitor pattern, et cetera. Because the visitor is it's not trivial. You know what I mean? The shaper, they're not trivial. We did do some work in there that was specific to mostly pointing to the correct query enumerator. right? Because we had to have one specific to Couchbase, and it uses the RSDK instead of ADO.NET. But yeah, it was that was a key integration point right there. There's a few others too. They're a little more subtle, and I'm sure as we go deeper in, we'll find more. But that was it. I think there was like 3 places I really found, and I'm going to miss the third one. But the first one is SQL Generator. The second one was translators. And the third one was, there's one third one I can't remember off the top of my head, but that was one of the other key integration points that once we kind of discovered these things, it was actually a matter of removing code and going straight to there and providing our implementation. I think type mapping was one of them. Type mapping was difficult. Some challenges there. I don't know if we 100% got it right. And there's I'm sure there's some place, so there's improvement, place for improvement, but.
And yeah, you are absolutely right. If you look at the other providers, or if the viewers would look at the other providers for Postgres or Firebird or MariaDB or others, you will see that most of the work is done in the SQL or query generation, because then you need to basically create a dialect for your database. Even though it's a relational database, there will be small differences in the syntax or what functions are supported and whatnot. And obviously then the translators, because these are the places where the functions are actually translated, and even simple stuff like string concatenation differs between the databases, or substring or something like that, or getting current date time, different functions, different syntax. So this is where most of the work for providers is, at least at the beginning. Once you start fine-tuning and everything, then it's visitors and everything around it. Yeah. There is one question that I want to address. It's not for you. And it's, could you tell us the differences between EF Core and EF Core Relational? Well, I mentioned it a couple of moments ago. The EF Core is the base package, and it has 0 assumptions about what the store is actually going to be. It can be documents, it can be key value, it can be relational stuff. And the EF Core Relational brings into the EF, into the main package, the relational concepts. So from point of view of developer, you can call toTable or has column name. So it basically maps to tables and columns. But under the hood, it's also a huge layer that's creating the translation from the link into relational concepts like tables and columns and left joins and inner joins, and so on. So you don't have to deal with this one. Obviously, some parts of this world, of this relational world, can be reused in other databases, especially if you're like a Couchbase and you have some form of SQL dialect. And some concepts are absolutely non-transferable to other worlds. If you look at a Cosmos provider that's based only on the EF Core, not on the relational, you will see that some places are implemented completely differently compared to, for example, the SQL Server or SQLite that's available in the repository as well. With that, I have one last question that I saw in here that will be great to cover, and then we can wrap up. And it's this one. What makes Couchbase stand out? What's its killer feature?
Yeah, that's an interesting question. There's a lot of killer features, honestly. I'm going to say the performance and scalability are major. Those are the big things, and ease of use. The scalability is just, it's different. It's much easier to add a node. It auto shards. So let's just say you add you're adding more documents and different keys. They will get auto sharded out to the cluster itself. You add a node, it'll auto shard everything. It'll redistribute everything throughout the new cluster configuration or topology, excuse me. So that's one of the major, is like I said, it's a performance, a scalability. And on top of that, you have things like SQL++, right? So now you're this familiar, if you know SQL, you pretty much, SQL++. So you can carry that with you. It's not like it's this completely different dialect that you go and you learn and it doesn't go with you somewhere else.
Absolutely.
You can apply it to even other databases, I'm sure. So if you became an expert at SQL++, you could just as easily switch over to, say, Postgre or SQL Server, and apply what you know. I mean, there's going to be some changes, but those differences are the same as, I mean, every SQL++ implementation is slightly different. But I'd say there's a whole package. There's a lot to it. You asked, there was some question about
I think Matthew, your colleague, posted a great list as well.
Yeah.
He said SQL for JSON is my favorite, but also built-in cache and offline first mobile database sync, which are definitely great features. With that, if people want to try Couchbase, where can they download it? Do you have like some test version or something like that they can install, run Docker container, and play with it?
Yeah. So even better than that, we have what's called Capella. And so that's a cloud offering, and it has a free tier.
Awesome.
So you can go to Couchbase, sign up for the free tier, and basically it makes everything super easy. You don't have to, like, if you want to build a cluster, you just build it on the free tier. It does it for you. You want to add a node, remove a node, it's like push button. It's much easier than, say, doing that, building out your cluster yourself. Obviously, if you're inclined to do that and you want to do that, you can do that with on-premise. But we have cloud. Like I said, we have multiple cloud offerings. I would suggest that you go towards the cloud offerings because they really make things a lot easier. If you just want to, run a local instance, that's really easy as well. You can just run it on a single node on localhost, or you could use a Docker container itself, and we have Docker images available, online. So yeah, you have multiple. There's multiple. There's multiple ways entries into Couchbase, and a lot of it depends on what your needs are. If you just want to get up and going, I do suggest those Capella free tier, or like I said, a local instance is also nice, or Docker as well. Either one of those. Yep. I would not suggest though you try to do distribute. Like, I would say if you're going to use Docker, this is my opinion, just do a single node. It's a lot easier. If you just want to play with it, just do a single node. There's no reason to have a cluster unless you need to scale. You have that for just getting up and running with it. Keep it simple. Capella first, or local instance, or Docker, one of those.
Awesome. Perfect. So that was a lot of fun. I learned a lot of new things. Hopefully the viewers as well. Thank you for coming on the show. And I'm pretty sure we will be in touch once you have new features or some killer new stuff available. We would definitely like to have you on show again.
Great.
Thank you again, viewers, for questions and the discussion. We will be online again roughly in a month. So keep an eye on that one, and see you next time.
Yep, thank you.